After that, we have stability. If you think of the stability of object, you see the same object. Here we have three positions. Three positions here, and it is most stable in the left side one, right?
Yes.
And the middle one is, if you just have little bit movement of it by any means, then it will fall down, right?
Yes.
And the third one, you see, is neutral equilibrium, is not like the first one, and even not like the second one, is a medium of that, right? In
Yes.
middle,
Like there's a 50-50 chance
yeah.
to be stable or something, right?
So is staying in stable condition, but it will now move, right? It will roll down.
Yes.
Okay, so that
Yes.
is called neutral equilibrium. Now, in our daily life also, you can remember, or you can check that the marker, you can keep it in a stable position, but not that much stable. But if you think of a book, it is very much stable, right?
Yes.
uh, in our house, we had a jug jug of water, which one has the lower surface area, that is touching the uh, ground, or touching the surface of the table. That place is not that much wide. Uh, the lower surface area, if it is not wide, then we saw it, sometimes it is falling down, right? And there was
Yes.
falling of water and mess in our house. Then I plan to buy now, because we have small children in our house, so they are not that much aware when they, uh, for any reason, they are passing by the jug, or they want to take water. That time they cannot have the balance. But now we bought a big, another one, which one has lower surface area, bigger. Okay, then we see that it's not happening like before. Now it's quite stable. So from that idea, we understand, if the uh, lower surface, or the base of the object is more wide, then it is more stable. Okay, and if the center of gravity, you see here, for the first one, we compare with these two, huh? For these two,
Okay.
uh, if you see, the center of gravity is somewhere here, right? If you think of that,
Yes.
somewhere here, right? So
Yes.
if it is here, then you think of both the positions. Here, the first diagram, you see center of gravity is lower, right? And here, center of
Yes.
gravity is higher place. So if the center of gravity is in lower, much more lower, then it will be more stable for any object. If it is lower, the more the lower center of gravity, the object will be more stable. So during buying any object in your house, we in our house we have to check it, that center of mass is lowered and the base area is wide or not. Otherwise, there is, risk of falling or topple it, right? Isn't it?
Yes.
So here you
Yes,
write
sir.
this one, huh? Uh, only this part you write, huh? You write the heading stability and only write these two diagrams, stable equilibrium and unstable equilibrium.
Okay,
Actually,
sir.
in your O level, we are not dealing with a neutral equilibrium. We are only dealing with stable and unstable, these two. Okay.
Okay, sir.
Once you are done with writing and drawing, let me know, huh?
Okay, sir.
Are you done?
Almost.
Hmm. Your bars are also saying almost with you.
Oh, again like this.
So they can speak these birds.
No, haven't taught them yet.
They understand your language. Do they?
Sometimes and sometimes don't.
Like if we have pet like cats or dogs, then we call them, they understand. Yes, we are calling them.
Sometimes when I call them, they understand. And then if I take them out of their cage and I call them, they would come sit on my shoulder.
Hmm. Okay.
Just starting.
Done.
Just start.
Okay, very good. Now, sorry. Okay, now here we are having the gist. Huh? Here we have the gist. So this one, right? Huh?
Okay, sir.
What I discussed, all these things are given here in the table. Okay. So
Sure.
I, yeah, did you take the printout of this note?
Not yet.
Okay. I saw that you shared from our Google Classroom. You shared it to someone's email,
Yeah, yeah, I did.
but yeah, it's not possible to
It's
get by
okay.
them from
Actually,
the,
I normally create a copy and then share it,
yeah,
and the copy becomes mine.
yeah,
So I don't know what happened this time. Instead of sharing the copy, I shared the original file.
yeah. You have to download it, huh? You
Mhm.
have to download it
Yeah.
from here. Then you can send it to someone from that
Yeah.
device. That is the
Actually, the
way.
thing is my laptop. Actually, there's some problem with my laptop. The virus got it and it crashed. So I had to use my phone, and there was a problem.
Yeah, yeah. Only student can have access here. The others they cannot. With any other email address, they cannot
Yeah.
get it. That's why I got the message that you shared with
Yeah.
someone.
Normally, I create a copy of it and
Yeah.
then I send it. So it doesn't ask permission. I don't know what happened this time.
So
I
hopefully
think
you are done,
with
right?
laptop it doesn't show problems. Yeah.
So you are done with this, right? This part
Yeah.
writing. Okay. So our this topic is done. Now we are having the worksheet on this topic today. Alhamdulillah. Excuse me. Can you see? Are you
Yes,
seeing?
sir.
Okay, so can you
Yes.
read the question?
And this is part number one. The diagram shows two objects that are being balanced. The being balanced is in equilibrium. Which quantities may be different? I think it's A, the masses of the two objects.
Uh, why?
I mean, it's in equilibrium when the moments are equal, right?
Yeah, in equilibrium the moments are equal, and
Yes, for example, when we consider a seesaw, if we increase the distance but the weight, I mean mass is less, and it still has the same equilibrium as on the other side, right?
if the moment are equal, then here we see the pivot and the distance of both the objects. They are also in equal distance, right, from the pivot.
Yeah,
So if the distances are equal, your moments, of course, your moments are equal. That's why it is balanced. It is equilibrium. So the forces should be also equal. If forces
uh,
are equal, that means your weights of the objects are equal. And as it is in the same place, uh, we are not like two objects are in two different places. They are in the same place of the earth, right? So
yes,
we can say their masses are also equal because gravitational field is still the same for them. So masses should be also equal, isn't it?
yes.
So masses are equal, moments are equal, and weights are also equal. And now the last one, volume could be different, right?
Volume.
Volume
Yeah.
could be different. So the answer is C. Is it clear?
So could you please wait? I want to take some notes from this.
Okay. So should I write here?
No, sir. I can do it myself.
Yeah, you can write. You want to write something or we can go to next question.
Okay. Wait, I want to note down something on my copy.
Okay. Okay, no problem. Then question two. Continue.
Yes. Which object is in equilibrium?
Yeah.
I think it's B.
C.
B for Bangladesh.
Bangladesh.
Yeah.
If look your forces, how they are working.
Um,
They
opposite
are
axis.
working from opposite side, but their position, position of the forces you see are working in a way that we have turning effect, and the turning effect will be anti-clockwise turning effect. That is rotation of the object, right?
Yes.
So here we will not get equilibrium for Bangladesh. But if
Oh,
you see uh, option C, if you check out option C, then you'll see they are working exactly uh, in the same line, in the opposite, right? So in this case,
yes.
we are having, they are canceling each other, then it could be equilibrium.
Okay.
So is it clear?
Yes.
Now three.
A wooden bar is pivoted at its furthest so it can rotate freely. The forces are applied to the bar, um, in which diagram is the turning effect rated.
Yes.
I think it is B.
Excuse me.
Uh,
Which one you thought?
uh,
Bangladesh,
B. Yeah.
Dhaka, or Bangladesh?
No, 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 no. Bangladesh.
Bangladesh.
Yes.
Can you explain how it is Bangladesh?
Um. Okay. The first one, the both forces are acting in opposite directions. They have the same distance from the pivot, so they will most likely cancel each other out.
What about
Then C.
A?
Yes, I'm talking about A. I think I'm not sure exactly. Is it A or B?
Yeah,
I'm getting
for
confused.
A you see, you are getting the distance from the pivot. Uh,
Yes.
the distance from the pivot is most for both the forces, and
Oh, now I got it.
yeah, and this one is also anti-clockwise rotation. You are getting the highest, right?
Yes.
Yeah, turning effect means it will rotate, right? So in A and B, A and Bangladesh, these two we are getting the turning effect. For C and D, we are not getting any turning effect.
One thing.
Yeah, that's why we will not choose C or D. We will focus A and B, Bangladesh. Uh, in Bangladesh, we have this force. From the pivot, we have this force far away and this force almost half the way, right? But here, for both the forces, the distance is most, right?
Yes.
So we will have here a greater moment, right, than
Yes.
Bangladesh. So A will be greatest turning effect.
Okay.
Now 4.
The total weight of the load on the wheelbarrow shown is 600 newtons. What is the size of the force S needed to lift the loaded wheelbarrow?
Can you do the working on your copy?
Yes, sir.
Are you using laptop or mobile
Phone.
phone? Okay. Adita, have you got the answer?
I need to think. I'm stuck. I'm not sure. I think it's C600.
Which one? 600?
Yeah, I'm getting confused actually.
Which one? A or C?
Hmm.
C.
I'm confused.
600 Newton. Okay. How can you explain?
I'm confused myself.
You did any working?
Kind of.
Yeah. Should I give you some clues? Like
Yes.
you know about. They are saying at the beginning. You see, 600 Newton is the weight, right?
Totally.
Yeah.
Yes.
Weight is working downwards, and they are saying what force what force is needed to lift the wheelbarrow, right? So it's showing
Yes.
or it's giving the idea that it is the point, it is the last point of equilibrium. Okay, in that force,
Yes.
uh, we can have the object balanced, the whole system balanced. So our pivot is there, right? Always during the calculation of turning effect of forces, we have to focus where is the pivot. And here we are getting equilibrium, anything equilibrium. That means we have clockwise and anti-clockwise moments are equal. So you write here in your copy, clockwise, uh, clockwise moment equals anti-clockwise moment. Okay, so uh, now what is our clockwise moment and what is our anti-clockwise moment? From the diagram we'll check. Our pivot is here, right? And from pivot,
Yes.
if you think this way it is working in a way, its turning effect will be clockwise, right?
Yes.
So the clockwise moment will be the product of the force and multiplied by the distance from the pivot. Here our
Yes.
force is 600 newtons. So right here 600 newton times 70 centimeter. Okay,
Okay.
equals anti-clockwise moment means the force. Force we have, that one is F, and distance from the pivot how much?
70 plus 50, 120 centimeters.
How much?
120 centimeters.
120 centimeter. Very good. So this is the tricky part. Sometimes students take only 50. Okay. Uh, this
Okay.
one you have to be very careful that always we have to calculate the distance from the pivot. Now you can get your answer. Tell me the answer now.
Okay. It's 350 Newton.
350. A.
Yes. Yes.
Yes, your answer is correct. Now it's now correct. 350 newtons.
I got a little confused in the distance
Okay,
of the clockwise movement.
are you using the mobile? Which one you are using? Emo.
Yes.
The same mobile you are using Emo, and now you are doing the class. Then you can have a snap, right? Take a screenshot and send it to Emo.
Um, I'm sorry, but I broke the power button on my phone.
So it's not possible, right?
No.
Otherwise, we could use this. You use it for our resources, right? Let me
Yeah.
check that I can do it or not. I can do it from my laptop, but it will take time.
Yeah. I
We'll
mean,
see
it's been
who
a
top.
week. I did my power button, and now I can't fix things up in
No
any
problem,
class.
no problem.
Yeah.
May take it there. Batch 8. Yes, today is 7 11 2021. Okay, done. So we are having a break, huh? Now the break will be till 5:50. Okay, 5:50 we
Okay.
will start. Okay, thank you, huh?
So,